Hello everyone. In this session we are going to learn about the logical operators and bitwise operators. Logical operators are pretty simple. We perform the logical operators on the boolean values. They include logical AND, the symbol for which is double ampersand sign, logical OR, the symbol for which is pipes, and logical NOT, and symbol for which is exclamatory mark. Let us say we have two boolean values. Boolean A is equal to true and boolean B is equal to false. When I do something like boolean A and logical AND boolean B, the resultant is going to be false, because to make the resultant as true, the AND operation needs all the conditions to be true, all the operands to be true, then only the resultant AND is true. Similarly, if we do something like A or B, the resultant is going to be true itself, because OR needs any of the operands to be true. If any of the operands is true, if any of the condition is true, the OR resultant is true. So in this case, the second output is going to be true. And the logical NOT is simply flipping the current logical state. So current logical state for A is true. So when you do not A, it is going to give us false. So that is the third output over here. Pretty simple. Logical AND, logical OR, logical NOT. Simply use these symbols and add your next condition. So if we have another condition, another operand over here, I will add it over here. Let us say C, for example. Okay. In addition to these, very importantly, we have some bitwise operators. Bitwise AND, the symbol for which is a simple AND sign, and bitwise OR, the symbol for which is single pipe, and bitwise complement, very useful, and the symbol for use which is this tilde sign. The use of these bitwise operators is for numbers. When you use these bitwise operators for numbers, they first convert the integer numbers into the binary and then perform the AND operation or the OR operation or the complement operation. Let us try to understand this through an example. Let us say I have an integer num1 is equal to say 60 and integer num2 is equal to 42, for example, and I perform a bitwise AND operation on them, a bitwise AND num1 and num2. And let's take a look at the output. Output is 40. How this 40 is coming? When you do a bitwise operations, the num1 will get converted to its equivalent binary format, which is 111100 for 60, and this 42 will get converted into its binary equivalent, which is 101010, and then the AND operation will get performed on them bitwise. And when I say bitwise, the resultant for the AND going to look something like 11 is 1, 10 is 0, 11 is again 1, 10 is 0, and 0 and 1 is again 0, and 0 and 0 is 0. And if you again convert this binary into a decimal equivalent, it is going to be 40, which is this output over here. When you do a bitwise AND or bitwise or bitwise complement, it is first going to convert the integers into the binary equivalent and then going to perform the AND operation. And whatever is the resultant binary, it's going to convert back into decimal and give you the output. So in this case, for example, if we do a bitwise OR operation, output is 62 will come from bitwise OR on these each binary digits, like 11 is 1, 1 or 1 is 1, 1 or 0 is again 1, and 1 or 1 is 1, and 1 or 0 is again 1, and 0 or 1 is again 1, and then 0 or 0 is 0. The equivalent for 111110 is 62. That's what is the output over here. Bitwise complement though is pretty interesting and very useful. What bitwise complement does is, if you do something like num1, it's going to reverse the logical state of each each bit. When you flip every logical state, it's going to look like 0 0 0 0 1 1. That is what this tilde is going to do. So three operations in the bitwise: bitwise and, bitwise or, bitwise complement, and three operations in the logical: logical and, logical or, logical not. And then there is a very common interview question asked, is what is the difference in between a single and double and, or a single or sign and double, this double pipes. And now you know the answer.